Balu Balakrishnan, you are the CEO of Power Integrations, and you gave the opening speech here at our Leistungshalbleiter Anwender Forum. So Balu, the subject of your keynote was the power of integration. With digital semiconductors like microprocessors, integration is done since decades. But for power semiconductors, integration is not very widespread. Why is this so?
Well, there are many reasons. The first one is integrating high voltage and low voltage on the same chip is very difficult to do. I mean, we did that many years ago. And the second thing is the packaging is very critical for integrating power semiconductors. You have to be able to dissipate heat, you have to be able to handle large changes in temperature, you have to be able to handle high voltage, and in our case we also have to meet safety. So all of those things make it difficult for anybody to just go and integrate them. So you have to really develop these technologies over long periods of time and be comfortable that it's very reliable before you can bring it to the marketplace. And that's all we do, and we've been doing this for 30 years. So we have developed a lot of know-how and technologies, and that's why we are able to do that.
Fluxlink has opened a whole new world for integration. So what did you achieve with this technology?
Well, first of all, we use it as a safety isolation to integrate primary and secondary together in a single package. And so we have a lot of products now in the marketplace. We probably have sold close to 1 billion of these chips with the safety isolation built in. But wherever we can use that safety isolation, we can use Fluxlink. The example I would give you is our iDriver. We have an iDriver for IGBTs, an iDriver for silicon carbide. There we use the same Fluxlink at actually much higher frequencies to enable communication between the primary side and secondary side to pass on information on how the MOSFET or the IGBT is doing, and also to very reliably pass information on turning on and off the MOSFET, the fault requirements, or fault feedback, and so on and so forth. So it can be used anywhere you need very precision, high-speed communication, and at the same time you need isolation, whether it's functional isolation or safety isolation. So we expect to use Fluxlink in a lot of new products that will be coming up in the future.
So a few months ago, you publicly disclosed that Power Integrations is using gallium nitride. And what makes gallium nitride so suitable for integration?
Well, first of all, you can make very low RDS on devices, so you can reduce the conduction losses dramatically with a very small die size. If you try to do the same thing with silicon, the die size will be so huge it won't even fit in the package. You have to make very big packages. That's number one. Number two, it has very low switching losses. In fact, cross-conduction losses are zero, essentially, not measurable. You still have some capacity losses, but the capacitance of the gallium nitride device for the same RDS(on) is orders of magnitude lower. So the capacity losses are very small. So the combination allows us to put very high power levels in a small package without a heatsink. So for example, currently we are able to do 100 watts of power delivery in a package that can barely dissipate 800 milliwatts. And you can't do that with any other technology. You have to have GaN.
So on the other hand side, I know it is very critical for gallium nitride to switching the parasitic inductance. So this is another key issue you have solved with your technology, isn't it?
That is absolutely true. One of the reasons I think gallium nitride is much better used as a integrated, fully controlled solution is that we can actually control the switching characteristics so that it doesn't generate high frequency oscillation, doesn't generate very high DVDTs, which can cause EMI problems, and at the same time also protect the transistor. One of the nice things about GaN is the switch is very fast, but it also means that if you have a discrete GaN, it's very hard to control how it switches, and it can cause all sorts of problems, including protection is almost impossible to do with a discrete GaN. And so in that sense, GaN is much more suitable for integration than as a discrete device.
So, Balu, thank you very much for the interview.
Thank you, Ralph, for inviting me here.